Hey class, I wanted to make a video here to give you guys a few pointers on the first couple pre-lab questions for you on lab number 2, just to make sure that you have these concepts down correctly so that you can get the correct theoretical values on your lab number 2. So, just to recap, we're looking at the first part of the lab here where you have your marble here, which let's go ahead and label that maybe 0.1 in time. Your marble is going to start on your ramp at some initial distance d up the bottom of the ramp at an angle that I've labeled here. Your marble then is going to roll down, eventually arriving at the bottom of the ramp at some later time, which we'll call that 0.2. At that point in time, it's going to be moving forward with an initial velocity that we're being told to call v initial x. And then it's going to fall off the table, eventually landing at some distance r, the range, away from where it started. So I ran out of floor. I'll extend that. All right, so this is what we're looking at here, and we'll call this maybe 0.3 in time. So the marble, we're going to consider it at 3 different points in time. All right, pre-lab question 1 asks you to, so let's see, question 1 asks you to consider what happens between points 1 and 2. As the marble rolls down the ramp, it asks you to figure out that initial velocity at the bottom, which it calls Vf. The final velocity for the ramp section is going to be the initial velocity as it goes off the end of the ramp. So it's a little confusing. That's why I wanted to clarify for you guys. Then question 2 asks you to consider from point 2 to point 3 and find the time that it's going to be in the air. And then question number 3 on the pre-lab asks you to once again consider points 2 to point 3, but determine the range or that horizontal distance that it's going to travel. All right, so numbers 2 and 3 are directly related to one another, but I think some of you guys are having issues, especially with question number 1. So let's go ahead and consider question number 1 first. All right, so in question number 1, we have a situation where our ball is going to be rolling down the ramp. I'm going to, draw another kind of zoomed in picture. So here's our ramp, all right. It's at some angle theta. Okay, maybe it's 20 or 30 degrees, depending on the problem. All right, and the ball is going to be rolling down some distance d. Okay, so if we start with the ball up here, and it's going to move down some distance d. Now we're told in the problem, we're kind of given a hint to use one-dimensional kinematics. So what that means is we're going to have to look at its motion as it's moving down the ramp. In order to do so, we have to know something about its distance, its time, or acceleration in order to figure out what its velocity is going to be down at the bottom of the ramp. So let's go ahead and label a few different things here. Probably we want some axes, so I'm going to make some axes here. So we're going to go ahead and call down the ramp the x direction. And so we're really going to just consider the x direction. So we have our x initial, let's go ahead and call that 0. We can call our final x position the distance d that it's traveled. Since we're releasing it from rest, let's not go with initial velocity. I'm going to, instead of calling it initial velocity, since that might cause confusion, I'm going to call it v1, the velocity at position 1 in the x direction. We know that's 0 because it starts from rest. And then the final velocity at the bottom, v2x, that's what we're trying to find, which is also referred to as v initial later in problem 2. Okay, so that's what we're trying to find. The time it takes for it to get to the bottom of the ramp, we don't know. But what about the acceleration? Now, at first glance, you might think, oh, I don't know the acceleration because it varies dependent on the angle. But what we do know is that our ball here, I'm going to go in blue, all of its acceleration is a result of gravity, which is straight down. Well, if you do a little bit of geometry here, if this is my y-axis and this is my x-axis, as we've already labeled, okay, you can prove this with geometry, but I'm just going to tell you that this angle right here, believe it or not, is the exact same angle theta as the ramp makes. So the component of acceleration down the ramp is the opposite side of a little triangle made with gravity. So it's actually just going to be equal to g multiplied by the sine of your angle theta. And you can again prove that with geometry, but for now I'm just going to give it to you as, yeah, a true statement. So with that information then, we can go ahead and solve for the velocity at the bottom of the ramp, that v final. To do that, we're going to use the equation v final in the x, in this case v2x squared, is going to be equal to v1x squared plus 2 times our acceleration times x final minus x initial. Plugging in our values that we know, this is 0, this is 0, x is d, v2 is what we're trying to find. So we have 2g sine theta times our distance d. And so our velocity then, I'm going to have to scroll down to give myself a little more room. My final velocity that I'm trying to find is just going to be the square root of 2g sine of the angle theta multiplied by our distance d over which we're moving. So that can tell you what the velocity is at the bottom of the ramp, which happens to correspond to the initial velocity when we get into part 2. Okay, so now for part 2, question number 2 here, we're considering the situation when we're leaving the ramp. Okay, so again, you're going to have to think about, and I'm not going to solve these out all the way for you, but I trust that you guys can figure it out. You need to know that what you have is you have an initial velocity in the x direction, which you just found, okay, from question 1. You know that your initial height is h, your final height is 0. You can now redefine a new x initial at point 2, which is also, you can call 0, and your final x at point 3, you can call your range r. With those variables, you can solve because you know that at that point, your y velocity is going to be 0 meters per second. Your acceleration in the x now, because you're in normal projectile motion, is going to be equal to 0 meters per second squared, and your acceleration in the y is just going to be negative g. And so with those things, you should be able to solve first for the time and then for the distance r. Okay? So keep in mind now, this can get confusing with these different subscripts that we have here. All right? But you might want to go back, maybe instead of calling this y0 and v initial in the y direction, and maybe even x initial, we can just call all of these in terms of the points in time. So maybe call this v2x, call this y2, y3, and v2y as well. So I hope that helps you guys get started on these. If you have additional questions on how to do question 2 and 3, go ahead and let me know. But I just want to make sure you're doing them right. So let me know if you have any questions in addition to this. Thanks.